Okay, so apologize about that. Duvid, we are live. I had myself muted, so I'm just going to apologize about that. Check the sound. So sorry about the close up on my hand. And I'm going to try to get my camera in focus. So sorry about the boomer tech. Okay, so here we have, which is going to be my stream on my math and physics books. So thank God I've been doing this for a few months now, like over a month now. Tour of my library. I started with the 13 books that changed my life, and from there I've been doing various parts of my library. Obviously, the most questions I get I haven't got to yet, which is related to my Jewish section of my library, and then also my consciousness section. But I have to organize my library, and I'm doing it kind of just haphazard. And this is a very important part of my life, math and physics. Anyone who watches Week in Review with the Church of Entropy, who possibly will join later for the stream, knows that the main topic of the show is math and physics, consciousness, and later I'll have parts where I'll talk about my psychology books, probably my business books, and consciousness books. So possibly over the next month, I'll try to do a show on my business books, my consciousness books, my psychology books. I want to do one on Gurdjieff, and I'm going to do one on my Christian books, and maybe political books, and then my Jewish books. And my Jewish books will probably be broken down into a few different sections, because my Judaic section is the largest part of my library. So I'll consider how to do that. Hanukkah's coming up in 2.5 weeks. So probably Hanukkah, maybe I'll try to start to do Judaic books. So we'll see what's going on. So actually, I just bought and built this shelf this last week. So Friday I got the shelf in, and I put it together, and then I put my math books all together. I have to reorganize, and actually you'll see that it covers more than this shelf. So I've already my math and physics books. I'm going to rearrange. I think I have a few other books. So let me just mention here, precursor, multiple truth hypothesis. So I had always loved math and physics. My father has a master's degree in mathematics from Kansas State University, and always had math and books around. Even these like type books that we'll look at. These Singer books, graduate study, advanced books on like set theory, number theory, and I'll go through some of these. A lot of these are my dad's books that he's given me, and I haven't really studied. It's beyond my level, although I hope to read those. So we'll go over those. And then my goal had originally been to get a degree in physics. Originally when I went to university, I thought I would get a degree in physics and go on to medical school, and that didn't work out that way. And I looked up the Ginsberg legends, Mark, just so you hear. And no, I don't have them. And the Ginsberg legends are just a collection. So I have similar books to that, but the Ginsberg books is just a collection of Judaic stories gathered from other texts. So I don't think I actually have the Ginsberg legends, but those are just collected and gathered from other texts. And Hanukkah, I'm going to try to Hanukkah times switch to my Judaica, but I have some organizing to do, and so I had enough math and physics books to create a whole math and physics shelf. It's possibly for consciousness. The other ones, I don't think I have enough for a whole shelf on another topic. So, civil engineering, Judaica, Hinduism, math and physics. I'm not sure I have enough, subject just. I'm also going to do one on linguistics. I've returned to the study of linguistics. So I had attempted at different points in my academic career to get a degree in physics, linguistics, and psychology. And I have a whole bunch of undergraduate credit, like over 200 credit hours. Usually need like 120 credit hours to graduate. And I have like close to over 200 credit hours. And all I have is a bachelor's. Because I switched around so many times, and I had attempted to major in physics, linguistics, and psychology. And, so I'll show some of my actual textbooks here, mathematic textbooks, and, look at some other things and, some interesting things. So just, mentioning when I came up with the multiple truth hypothesis, part of the multiple truth hypothesis is a logical mathematic algorithmic form that will be in symbolic mathematical language. And, so I'm still doing the research and, teaming up with Jennifer. Hopefully she's starting to take some stuff more seriously academically, like her writing. And maybe we're going to team up on writing a book on the history of signal processing. Because, probably my best expertise in the scientific field is the philosophy and history of science. And, so we'll start going over some of these books. And the books on the history of science, I've read those books, and I know much better than to say, like, these books that, like, if you actually had a master's degree in mathematics, or the type books that you would study from. And I browse through those. I try to spend regular time studying. Even now, like, I'm more reading the history of math and logic than actually the study of it. And, I'll talk more about it as I go through the level of computation when you actually take math and have to solve problems, like Lex Friedman saying that the best books are textbooks. Like in many ways, the best books that there are textbooks, where it has long explanations and practice problems of various levels to mastery. And, as my father said, you want to, do good, you should do all the problems in the back of the book. From I don't think I have any of the books that I had when I was in high school. Still, I didn't keep those, but I was a good student. I used to you work through all the problems in the back of the book. Usually, like homework, you get signed a selection of them, and like if you want to do well, you do all the problems in the back of the book. You really master all the various permutations, and then as I got to higher level of mathematics, it was too difficult beyond my possibilities. And a lot of solving higher level mathematics really involves writing computer programs and is significantly difficult. So, with that, let's get started. If I think Jennifer's not going to be around, I offered for her to come on towards the end of this after I finish going through my books, and we'll talk about possibly the book that we're going to collaborate on, which would be a history of signal processing. So let me try to actually resting this on my foot. So that's actually rested on my foot. And so this is the bottom shelf. And I kind of just bought the cheapest shelf. So, because in the long term, like, good shelves cost more money. And, so I have my heavier books towards the bottom, including my textbooks, and it should have more shelves, but this is just kind of like the cheap shelf. So a lot of these include actual textbooks that I used when I was in school, and then some other stuff that I'll probably move and set in different piles as I'm going through these that really shouldn't be here. So as I'm doing this, I'm also organizing my books. So this I'm going to move someplace else. This was a good course I took, Engineering 520 at University of Michigan. which was business for engineers, graduate course, popular course. People who went through the University of Michigan engineering school, a lot of them took this course. I've recommended this course. I'm not sure if it's the same professor is teaching, but was a one-semester course that basically tried to teach the basics of business for engineers, entrepreneurship. These are the course notes, and I ended up partners in my course, and we did a study on data centers. So some of these I'm going to move, shouldn't belong here. So I'll just show these because I'm not sure where I'll put them. I might create an engineering shelf or something for not civil engineering or math and physics, but engineering related books. I probably have a shelf for that I won't have room with my math and physics books. So this was the course I took at University of Michigan, Public Policy in the Ford School, Beyond Sputnik, U.S. Science Policy in the 21st Century. And it was a good course on public policy. It was taught by Homer Neal, who's on the board of directors of CERN in Switzerland, the particle accelerator, and Professor Duderstadt, who was the former president of University of Michigan and had his background in nuclear physics and was president of University of Michigan. There's the Duderstadt Center, but still teaches some undergraduate courses even. So that was an interesting course promoting STEM, science, technology, engineering, and manufacture from a policy point of view, the role of government. It was a very interesting course. Here, as I said, I was pre-med. This book was expensive. I'm not sure. It was like close to like $300. Principles of Human Anatomy. Wiley. This was University of Michigan undergraduate course that was taught by the same professors of the University of Michigan Medical School for Anatomy. And I'll probably put that someplace else. I have quite a few other books like anatomy books. I just had that there with my textbook. Here, chemistry. I think this is from Stony Brook. Chemistry, Olmsted and Williams. I took organic chemistry also. So I'm not sure if I lost my organic chemistry book or if I have that someplace else. I think this is just basic chemistry. I might leave that with my physics books, with my math and physics, because I don't have too many other chemistry books. But I took organic chemistry also. I probably still have the textbook somewhere. And so like Lex Friedman always said what are the best books that you read? And Lex Friedman would say like textbooks. You really have a chance to study and work hard in level of textbooks that you don't do till later. So covering textbooks. So this Modern Physics by Kenneth Crane. This was from University of Michigan course. Like this is the break for people who major in physics from introductory physics. And I think they had like thermodynamics, waves, and relativity in one course. So modern physics has the wave equation and relativity in one book. So this was, this is a good book. This was a University of Michigan textbook from a class that I took. Here's University Physics, Volume 1 and Volume 2. And I believe I took these at Stony Brook. And, this has your basic, sometimes they have physics divided up into 3 courses or 2 courses. I think Stony Brook had 3 courses for their physics, which would have been, classical mechanics, then thermodynamics, and then electricity and magnetism. So these were my freshman physics books when I I took that in Stony Brook University. And the student solution manuals. So, problems at the back of the book. You said a good student does all the problems in the back of the book. And, the solutions manual, usually purchase those, like to help sometimes actually work through the problems, or just look through the solutions manual to see how the problems are solved. This University of Michigan, believe, I think I took this course, University of Michigan, differential equations. We talk about that quite often. Differential equations is like the pinnacle of science. Basically, all engineering is eventually reduced to differential equations. And differential equations, it's just noted that the equation includes the present moment, the past, and the future. From the equation, that, as opposed to like regular calculus, differential equations will include the derivative within its own equation. So you might like f prime of x equaling x. And the point is that from the equation, you could derive the past and the future and the present states from the equations, and then the solutions manual. So these are courses I took in university. This is a really good book, Advanced Engineering Mathematics, Greenberg. I'm not sure like the quality of the textbook, but this was a course I took at University of Michigan. And at this point I realized that I took this course pass fail. I realized I wasn't going to be able to get a degree in physics. It was very complicated. High levels of power series, Laplace transform, second order, higher qualitative methods for solving differential equations, linear algebra, matrices, eigenvalue, some very complicated things like Fourier methods, partial differential equations, conformal mapping. This was just an overview of mathematical techniques for engineers. So most of these were centered around advanced methods for solving differential equations, because if you take science and math, you realize most differential equations are unsolvable. And so you need certain mathematical methods to solve them, and it's very complicated. So that kind of tapped me out. I took that pass fail. And John, thanks for showing up. Mark, Jugnarth, thanks. So that kind of tapped me out and made me realize I wasn't going to be able to get a degree in math and physics. Here's an interesting book. Isaac Asimov had written a book, Understanding Physics, 3 volumes in one, that is a non-mathematical explanation of motion, sound, heat, light, magnetism, electricity, the electron, proton, and neutron. I'm not sure if there are other volumes, but a good, interesting book. Isaac Asimov, I sell some of his science fiction books, but also had written on physics. He would, I think he had a background in a degree in physics. So that interesting book. Multivariable calculus. I think this was calculus 3 in university, where that deals with parametric equations, polar coordinates, vectors, 3-dimensional partial derivatives, various. So this was, University of Michigan textbook would have been calculus 3. And musical acoustics. This was a good book. I'm not sure if this was, I think I took University of Michigan a course called The Physics of Music. It was a good course. And, at that point I'd still been hoping to get a physics degree, and it wasn't that mathematically intensive, but, a lot of interesting, a lot of demonstrations that showed the physics of music, and, acoustics. And I think I have other books on that. So, that's a good book. This also kind of tapped me out. I took a lot of courses at the same time, and this is 400 level University of Michigan. I think this is a famous, well-known book, Classical Mechanics by John Taylor, which is the advanced mechanics for university upper level physics. Generally, say, but you take intro physics, could be divided into 3 levels of classical mechanics, electricity, magnetism, and thermodynamics. And then at the 400 level, you retake those courses at advanced, with advanced mathematics, including things like angular momentum, oscillations, Lagrange's equation, the Hamiltonians, rotational movements, things like chaos, perturbation theory, and the mathematics was really just too difficult for me. It was unfortunate. I passed the course. I took a pass-fail, but I saw I wasn't going to be able to get a degree in physics. Like at the time, I was already older. I was doing different things, and it became clear to me that it was going to be beyond my capability to get a degree in physics. Good book though, constantly returning to Hamiltonians and various things. So those are some of my university textbooks of engineering courses that I actually studied and took in university. Some of these I have the heavier stuff on the bottom, so these are kind of just larger picture books. You have the stars, the defining visual guide to the cosmos, National Geographic, the Space Atlas, the big idea, how breakthroughs in the past shape science. I have some geology books, the Great Lakes, the natural history of the changing region around the Great Lakes. Here's a series of books. My dad really likes these books. He gave me them on the periodic table, reactions by Theodore Gray, very good graphics, molecules, color, and the solar system. So I have these here just on the bottom because they're heavy. And another one, Jim Bell, the Space Book. So these are aren't really mathematical. They're written for non-scientists to explain scientific ideas. A lot of them about space exploration. So just continuing here. These are very interesting, and maybe I'll talk about this more. I had sought employment, and COMSOL, the multi-physics platform, is very expensive, costs like tens of thousands of dollars, and it's an advanced physics platform where you put in materials, and then it runs equations, differential equations based on various physics testing. So Michigan, you have the automotive. If you wanted to build parts to automobiles or test new ideas, I talk about this at some of the engineering shows. COMSOL is usually there. And so I trained on COMSOL multi-physics. I don't own the software because it's very expensive. But you have great software. So these I kept their, how to set up and the basic operation of it. And some of these were very good. They're overviews of, so when they were training, a lot of times they talk about like hyper-elastic seal, heat sink, heating circuit. So these were different modules where they trained how to do something specific with it. And they have various modules, and all their modules are very expensive. And so great software, COMSOL. Maybe at some point I would buy their software. They're very expensive, cost tens of thousands of dollars. They had COMSOL at University of Michigan, and I knew certain companies or people that use the software, and they used to offer free training. This one, battery and fuel cells modules, were just showing how to use COMSOL to test various software. So I've kept these booklets for the software. I also have stuff in like CAD. I've trained in AutoCAD, introduction to heat transfer module, structural mechanics module. So I kept these COMSOL training manuals. Maybe, I kind of dreamed about buying their software one day, but COMSOL, as I said, it's extremely expensive. So, cost just a, starters modules like $5,000, $10,000. And if you want the, that just does one, it's called multi-physics. So that just tests one aspect, like their battery module, or physics module, chemistry module, thermodynamics. And if you want to test multiple systems, like, their complete batch of software would be tens of thousands of dollars. Although, a lot of the major companies in Michigan have the software. University of Michigan have the software. Tech shop, pretty cool tech shop, went out of business. I was a member for a while. I trained 3D printing, laser cutting and etching, laser engraving. I also took a CNC machining wood shop. So it was a pretty cool idea. It was set up like a gym membership where you paid a monthly fee, and then you could use machine equipment to like CNC machining, laser etching, and various things. They went out of business, but it was a pretty cool idea where the concept was that you would pay for a monthly membership, and then you could use their machines like a gym, but it was mechanical equipment, and they had things like plastic mold injection, and they went out of business. So it sounded like a good business idea, but didn't last. My dad gave me these books. He really likes these books. God forbid I say, like, he reads these in the bathroom, and they're just big books of problems that have worked problems, kind of like chess puzzles, where you're just trigonometry problems that are worked. And hopefully I'll talk more like Kahneman, Tversky, and systems 1 and 2 thinking. So the key of mathematics, there's a philosophical take on what it does, what it's useful for, and then there's actually working problems. So the humongous book of geometry problems. And I'll sometimes look through these if calculus problems. You have a spare time, and just a good thing to do if your spare time is to work mathematical problems, to review algebra problems. To some extent, if you don't work with it, you lose your ability. So like algebra, trigonometry, geometry, calculus, differential equations, higher level mathematics, physics problems, chemistry problems, like organic chemistry, these type things. If you don't work with it regularly, you get worse at it. Kind of like chess, chunking theory. So these are good books. Shams, and my dad has like a whole shelf of these books, and he usually looks at them in the bathroom. Mastering algebra, just to keep your mathematical skills, that if you don't use them on a regular basis, you lose them. And so just reading books on the philosophical implications of math and physics is not enough. You need to actually work problems, so constantly be working problems. I used to look at these in the bathroom. I kept these for years. Like now I read engineering magazines in the bathroom. So like now I get like mostly at the conventions, but there's, you know, like Charged Magazine, all these manufacturers, sound and vibration. So I read, God forbid, you know, sitting on the can, I'll read engineering books. But I used to look at these, you know, like I said, like working problems with these little spark notes, quick study guides on topics, you know, physics, nursing, architecture, and yeah, I have a bunch. My dad has like hundreds of these also, and you know, they're pretty good, like vocabulary, German vocabulary, Hebrew, you know, so organic chemistry, like I was mentioning, synthesis, nomenclature, various things. So these are pretty cool. I'm sure a lot of people have these. They sell them in, you know, like the university bookstore. And I used to go through, and anyone that I didn't have, I used to buy. You know, even have African American history, and you know, geology and earth science, the Constitution, Hebrew, your verb. So, you know, these are pretty good things also. Just keep your mind sharp, you know, so, you know, to constantly be reviewing and refreshing. I mentioned, you know, many times Ebbinghaus's Forgetting Curve. I don't think I have a Hindi one. So that was Hebrew, but yeah, there's also like you know, I could probably get one on Hindi. I don't know Hindi that well, so these are, you know, like reviewing things. So it's hard to study and learn something from those. It's easier to review something that you've already studied. So a lot of this stuff on the second shelf here are physics books that my dad gave me, and you know, I'm reading through. I'm trying to study this stuff regularly. I've showed some of these on Week in Review. These are really great books. These are, you know, some of these would be our famous historical books, printings, and some of them are your graduate textbooks or review books to help study various things. So, you know, go through. Hopefully, you know, some of these I plan on reading through. So I'll show this quickly. I just read this book the other week, and Jacob Switchenberg, Teach Yourself Physics, and then he has a whole series of the no-nonsense, student-friendly introduction to quantum mechanics, electrodynamics, classical mechanics, and quantum field theory. So Jacob Switchenberg, and I might actually reach out to him to do an interview with him. So if I could get an interview, I think he's, you know, probably even younger than me, and he was studying for a PhD in physics, and he said he wasn't really that great at mathematics. And these are undergraduate lecture notes in physics from symmetry. And a lot of these are mathematical techniques for understanding physics. And he mentioned when he was getting his PhD, he wrote this, and, you know, he said that he wasn't really that great at mathematics. And he covers more theoretically, where he mentions, you know, the concept of when you're in school and you have to work a bunch of problems versus, you know, understanding what the ideas are and what the various mathematical techniques mean and do versus you're working a bunch of problems. And these books are still, you know, very mathematical, but they're not centered around problems. So they, you know, they explain the equations and what they mean and how they relate to physics concepts without focusing on problem solving. So I have his whole set here, and I just read his Teach Yourself Physics book, and hopefully some point soon over the next month or so, I'm going to start probably with the, you know, classical mechanics, then electrodynamics, and then quantum mechanics and quantum field theory, to try to pound through his books, you know, just my regular study, and eventually they'll be useful for the multiple truth hypothesis. This is a very good book. I actually sold this book also, the American Mathematical Society, An Illustrated Theory of Numbers. And this one was kind of expensive. I think I even got like $100 for this book. I sold the one I had that was in better condition, but it has, you know, latest computer graphics in order to understand prime factorization, Euclidean algorithms, Gaussian integrals, modular dynamics, various various topics in mathematics using graphical methods to help explain them. An extremely good book, Martin Weissman, An Illustrated Theory of Numbers, kind of expensive, but if you could get a hold of a copy of this one, very good book. Like Schwittenberg's Physics from Symmetry. And actually, I would like to interview Schwittenberg. I might reach out to him once I start reading his book. And I noticed he's on Twitter, and there's probably not that God forbid, they're not that popular physicists. So it's possible he would do an interview with me. So I might reach out to him. Here's Dover Advanced Calculus, an Introduction to Classical Analysis. So I haven't even looked at some of these books, but sequences and series, function, so just this also like a Dover book that doesn't focus on problems like a textbook, but has the explanation of the concepts of calculus laid out in one book. So here, move these around as I do this, so I didn't organize my library that well. So I just kind of put them so I have to think of what order. And God willing, God will give me the ability to have the time to study and comprehend this stuff. Time is limited, and obviously, I'm an old man already. God forbid I'm going gray. Time is limited, so I'm not going to go back to school and get a master's degree in mathematics. But I try to read some of these books in my spare time, and some of them, I have the dream. Even my father, he likes buying or collecting them, but to just go through and hope to read this stuff. So this is also a very good book. I think that this is a famous book. It's kind of expensive. It's a well-known math book, Proofs from the Book, Eigner and Ziegler, and covers extremely famous proofs of very famous mathematical ideas, and has nice graphical representations and explanations. So Proofs from the Book, very famous math book. This may even be undergraduate. This would be probably maybe even junior, or it might be graduate level, for proving famous mathematical theorems. Some of them are simple, some of them are quite complicated. Another Springer book. I have the whole set of Springer books. So anyone who knows math and physics knows Springer. So most of these my dad gave me, and these are kind of expensive. And so if you've taken university mathematics, you might know some of these books. Otherwise, you maybe never even seen these books, may never even know these things exist. So Propositional and Predicate Calculus, the Model of Argument, which is a different way of understanding calculus and framing calculus. I think this is also a well-known book among mathematicians. I'd lend books out. If I had a local friend or something, I'd lend books. So usually, just Paul in the chat. It's based on credibility. So I lend a book out, and a lot of people I just meet and they want to borrow a book. I'll lend them a book, and half the time I'll never get it back, and I'll even say I forgive you if you don't give it back. Some of these books are more expensive. So if you're someone I never met and hadn't built up rapport with, and you wanted to borrow, one of these Springer books that cost $100, I might be more hesitant to borrow it out, or if they're more difficult to get back. So, I have friends that I've been lending books to for years. A lot of people just buy them, but unfortunately, when you lend out books, about half the time you never get them back. So, if it's a rapport of someone I knew well, and they had, a reputation where, they always get the book back to me, and, they don't really damage the book. And a lot of these books also, like, books get in worse condition as you read them. Like, certain things like, being careful turning the page from, the side, or be careful for how you turn the page, not to damage them. So it's really tough to lend books out. They come back in worse shape. Like, half the time when you lend books out, you never get them back. But I do lend books. I do have friends that have a good rep. But a lot of times I just give books away, and I'm not sure. Like, if I was studying math with somebody, they didn't have as much money and wanted access to these books, I'd probably lend them. But generally, it's good to own the books for yourself or borrow them. Or just buy them and own them and keep them for reference. So these are great books. So God forbid, time is limited. Like, God willing, I would have the ability to get through these. So Steven Weinberg, one of the fathers of string theory. There's the Cambridge lectures on astrophysics. So a collection of Steven Weinberg's famous lectures on astrophysics, and then Weinberg's 3-volume Cambridge quantum theory of fields. And I forget what years these were written. So this was first published in 1995, and I'm not sure if Weinberg's still alive. But yeah, one of the fathers of string theory, of field theory, quantum field theory. I think a Nobel Prize winning. My father has the Richard Feynman. I actually think I gave my father as a present the Richard Feynman lectures. But these are famous books. Anyone in physics who has a degree in physics probably knows these books. Maybe has tried to read them. And said, like, hopefully soon I'm going to start going through the Schwichtenberg books. And then, if I got through the Schwichtenberg books, like if I did a chapter a day over a few months, I would finish them, and then it would maybe move on to the Weinberg books. This is a famous book my dad also gave me, Einstein's Gravity in a Nutshell by Z. And, this is advanced, very advanced physics on, curvature, space-time, field theory, gravity. So it covers, Einstein's relativity, special relativity, and then the theory of gravity, from. So I think this is also somewhat a well-known book. I actually tried flipping through it once years ago. I had a bookmark in there. I only got to the first chapter. Here's the Princeton Companion to Applied Mathematics. So there's 2 books. There's like the Companion to Mathematics, and this is really a great book. It has, if I had time, I would try to read this cover to cover. So maybe at some point also I'll put this on my desk, and I'll probably try to read a little of it daily, and just nice overview of applied mathematics. Huge book that covers whole gamut of modern mathematics. These are well-known books. So David Morin's a popular author. This one I'll probably eventually read through also. This one has very little mathematics. It still has a differential equations, but like relatively, I think it even has worked examples. But the Enthusiastic Beginner Guide to Special Relativity. David Morin. I think I have another David Morin book. So here's Jay Cummings, Real Analysis, a long-form mathematical textbook. Analysis is a type of mathematics, and so this would be a supplement to a course in you'll probably advanced level mathematics. I have more books on, but this also have Jay Cummings, popular author, long form textbook of proofs. So proof theory. God willing, I have time to read these books. Time is short. But you know, so these are just, you know, kind of like college level textbooks in mathematics. Abstract algebra, student friendly approach. So, you know, as opposed to algebra, you know, the concept of abstract algebra, um, a more upper level understanding of algebra, taking into account a lot of deeper mathematical questions that you know, in high school people already learn algebra in, you know, junior high school, but go, you know, don't cover the deeper mathematical, philosophical, logical questions of the basis of algebra. Um, this also, just because it's Springer, I had it together. I was talking about this 1 week in review: Ancient Landscapes of Western North America, Geological History, with the paleographic maps. So, you know, just a nice Springer book on geography. My dad has the whole series. So this is Euler's Elements of, not Bueller, Euler, Euler, Elements of Algebra. You know, one of the founders of mathematics, with the most mathematic theories ever named after any mathematician, possibly the greatest mathematician of all time, Leonard Euler. And this is his books on algebra. And, you know, talk on Week in Review. He was funded by, he was a member of the Royal Society of Bavaria, or you know, in Germany, and also in Russia, and you regularly publish books on various topics. Here, The Night Watch: Practical Guide to Viewing the Universe, and then it comes with these, you know, handy guides for finding stars and matching them up based on locating one star. So those are most of the physics books, or bigger books. So those are all, you know, really pretty good books. And you know, as I said, it's likely, you know, over the next little period of time, I will start the Schwichtenberg books and, you know, try to do a chapter a day. I'd like to go over this proofs from the book. Like this book, The Illustrated Theory of Numbers, is a good book. Physics from Symmetry, also. So, you know, of all of these books here, I plan on going through the Schwichtenberg books, and I actually plan on reaching out to Schwichtenberg and see if he even give me an interview. So he's on Twitter. And, you know, Einstein, the gravity books, the Weinberg. I would like to eventually, you know, do these things, read through these books. The applied mathematics, it's possible one day this will end up on my desk, and I'll go over it over a few months, you know, just reading a little section each day. It's kind of like, you know, like a 1-volume encyclopedia. And there's another volume also that my dad has, you know, the special relativity book. It's likely I'll try to go through that at some point. The geography book, I'd like to go through. These coming, you know, I'm not sure I'll ever have time to go through them. I would like to, but, you know, we'll see. So, oh, I read this book recently. Pretty good book, 48 Hours of Honor Calculus. So I read this over a few days. It was a nice review of calculus, and you know, just, you know, like I said, the problem books. So, you know, just functions and sets, sequences and series, continuity, derivative, Riemann integral, ordinary differential equations, functions of several variables. So just the, you know, nice overview of calculus. You know, it said, like, if you don't use it, you lose it. So here's the Pearson series. My dad has almost the whole series: Introduction to Linear Algebra and Algebra. And so these algebra is more than you would get. Like, this would be upper level textbook, or even a graduate level that would cover the deeper mathematical substructure of algebra that you know, when you just learn the techniques. So the Pearson series, my dad has, I think, almost the whole series. So you know, he gave me a few of these, and you know, I have a lot. Linear algebra is a very important subject, And so I have a lot of books on linear algebra and various things. So now moving up. So set my camera back. Okay, so this third shelf here are basically all upper level college mathematics books. And so these would be the type books if you were actually getting a degree or a master's degree in mathematics. Basically all of these books my dad gave me. And so my dad actually has a master's degree in mathematics, and like maybe one day I'll try to do my dad's library. He's got a whole room, probably 4 or 5 shelves like this just on math books. So these books here basically were all given to me by my dad, and I would like to study them. I may never have the time to study them, just to know that they exist, and to think them out, or to have them as reference, possibly, like if I got into the multiple truth hypothesis and trying to put it in a mathematical language, to have these books as reference. Some of these books are more valuable. I'll show my dad mostly looks at these books in the bathroom, but this one, for example, was one he started outlining. So my dad actually outlines these books as he reads them, and then he might reread them. So he'll read through it once with a marker, and then he'll read through it a second time. And he outlines, like in these books, he basically outlines everything. So I actually just read this one recently, Stilwell's Mathematics and Its History. Good book. Springer, all the Springer books are basically good books, and Springer books are kind of expensive and maintain their value. So a lot of these books are, some of them I have multiple copies and I've sold, but most of these I've kept for reference. And I actually have this right here in my kitchen. So like I stare at these books all day, so that my head will be trying to think about these things. So very good book, Stilwell, Mathematics and Its History. I'm going to look. I'll show the Springer books first. Like anybody who has taken advanced study in mathematics will know Springer. They're the most popular publisher of mathematics textbooks, a German company, and a lot of them maintain their value. So these books are actually kind of expensive. Here you see UTM. This means undergraduate text in mathematics, and they also have GTM, which is graduate text in mathematics. So here you have Introduction to Boolean Algebras. So Boole, who kind of the father of logic circuits, and a form of algebra that later came to be used for computer circuits. So it's Introduction to Boolean Algebra. Here's Understanding Analysis, Abbott. So your analysis is I guess a form of number theory and functions. So like the study of functions and numbers, they call like mathematical analysis. So when you have an equation like f of x equals, or the modern form, like I said, like advanced algebra, where these kind of questions of what's the origin of a function, there's a lot of more complicated things behind it that you just work with when you take lower level mathematics without really thinking about the deeper implications of what is a function, what is a number, what is a series. So analysis is one of the major fields of mathematics. If you get a master's degree, you could divide it up, like set theory, number theory, logic. Analysis is one of say the major fields. This is a famous book, Linear Algebra by Lang. So anyone who knows, anyone who's taken linear algebra probably knows these books. Linear Algebra by Serge Lang, and linear algebra includes like vectors, and for solving complicated problems, like eigenvectors and various things, you put them into matrices, and then you work with the matrices, and for actually solving complicated math. Linear algebra is one of the most fundamental tools, commonly used tools for advanced mathematics. So here's another Lang introduction to linear algebra. So Lang, Linear Algebra, Introduction to Linear Algebra. These are well-known books. So anyone who's studied at the university level mathematics probably knows Lang, one of the most well-known, respected textbooks in linear algebra. This is a really good book also. Kanamori's The Higher Infinite. Springer, this might be this a graduate level book. And people think like Cantor and set theory, and you have like countable infinities and uncountable infinities. There's actually a lot more to it than just that. So this would be, so if you're taking a book on set theory, you want to understand the infinite from mathematical perspective. This is one of the well-known textbooks, Kanamori, The Higher Infinite. And maybe I'll return to these books and try to give an overview more of the study of mathematics. So just trying to get through these. So Axler's Linear Algebra Done Right. You see on the cover Apollonius's Identity. So another kind of very popular, this is a popular book, a very good book, Introduction to Linear Algebra, Axler's Linear Algebra Done Right. So as also like mentioned, the Lang books, anyone who's studied, has a degree in mathematics probably is familiar with this book, Linear Algebra Done Right. Very popular, well-explained introduction to linear algebra. And I think I actually have another copy of that one up for sale. So I have, I actually have that one for sale also on my eBay page. Another one, Ross, Elementary Analysis, The Theory of Calculus. So I mentioned analysis could kind of be understood as the theory of a function. That also, set theory in relation to functions. What does it mean? Like signal theory, to have discrete units like numbers versus a set and a function. So Ross, Elementary Analysis. Check what the other book was, Ross also. So Abbott. So so those are all Springer books. So I'm just going to do all these Springer books. So Springer is probably the most well-known publisher of math books. My dad probably has like 100 Springer books. And so here's graduate text in mathematics, and you can see the number. So here's graduate text in mathematics, also Springer algebra. So here would algebra like in high school, but at a much higher level of understanding, including all the latest theory related to other branches of mathematics, or the precursors underlying concepts that are necessary for algebra, put together on a graduate level in mathematics. Model theory. So model theory, also related to algebra. But there's group theory, there's model theory, and so it's an advanced concept of mathematics. And I mentioned like analysis or higher level algebra. What does it mean to have a mathematical model? And then you have to have a theory about models, like a theory about theories. So you have a theory, and then you have a theory about theories, and to put that in a mathematical language, to develop the structure of the mathematical language. So so Springer graduate books, that's actually 217. So you see, like Springer has hundreds of these books. So that that's here's advanced linear algebra, graduate level book on linear algebra. A lot of these subjects you constantly return to. So another major publisher of math books is Burkhauser, and things also German. So if you're taking mathematics undergraduate, upper undergraduate, or graduate level, Springer is the most likely publisher of your books, but Burkhauser might be the second, and there's Oxford and Cambridge. So here's methods for solving number theory problems, and just a simple number theory could be significantly more complicated than you could imagine. Here's Introduction to Cardinal Arithmetic. So when you just think cardinal arithmetic, which you would think would be like something that you would do in elementary school, like cardinal arithmetic, but to put it in the language of mathematical logic is very complicated, and the certain philosophical precursors to that. Methods for solving complex geometry problems, and methods for solving sequences and series problems. So these are all these methods of solving Elena Grigorieva. So these are popular books like Introduction to Advanced Levels of Solving Complicated Mathematics. Set theory on the structure of the real line. So, an advanced introduction to set theory, very important part of mathematics. So what is a set? How do you work with sets? How do you define sets? So, here also set theory with a universal set. This is the Oxford logic guides. So my dad has like the majority of the whole Oxford logic series. So, just set theory within, the Oxford's science publications, and they specifically have a series on logic books. And so, this is set theory with a universal set that would be part of their logic series, and that would, be trying to define what a set is and work with sets in a logical language. Here is CRC, Introduction to Set Theory. Set theory is also a huge part of mathematics. Real and complex analysis, McGraw-Hill, Rudin. Recursion theory for metamathematics. This is also from the Oxford Logic Guides. Recursion theory. To remind myself what even recursion theory is. This Smullyan. Smullyan is a popular mathematics author. So you'll see later I have a lot of books by Smullyan, and he writes some popular books. Then he actually has textbooks. And so this is the sequel on Gödel's incompleteness theorem. And recursion, I guess, is a more advanced topic than Gödel's incompleteness theorem, and trying to simply define what is mathematics, what is logic, and through this concept of recursion of and the consequences. So I'm going to see if we carefully. Yeah, so hopefully at some point in the near future, I'll return and do a more advanced overview of these books. So for now, I'm just going to show these books, and hopefully in the future I'll come back and we'll do a more in-depth. So here's a mathematical introduction to logic. Big topic, so there's a lot of introductory books. Here's an introductory to the theory of numbers. Just number theory. Theory is a very important concept. Relation to set theory, like what is a number, how do you work with numbers, the various implications, how do you define it in a mathematically logical, consistent way. Here, the historical development of the calculus. This is a good book also. This book I actually read recently, and covers the ancient history of the precursor ideas of calculus in antiquity to like from Zeno to Archimedes into Newton and Leibniz and Euler and Riemann in the modern formulation of calculus. Good book. Here's the little book of bigger primes. So, just prime numbers and talking about big primes. I have some books on Riemann's zeta function, but your prime numbers is a huge topic in mathematics. And, so this is also a Springer book. Paul asking about how do you feel about people who write in books, putting notes. Well, my father does that. So you see some of these books that my father, came from my father, that he does that. I usually don't write in books. I used to at various points. Like it's a question of memory techniques or how you understand books. So generally I don't write in books. So these ones are pretty complicated. It's not much to say. These are all, say like graduate, upper level college textbooks in mathematics. There's Model Theory, another book on model theory. A different introduction to the theory of numbers, Oxford. I actually just sold. I had 2 copies of this. I sold one. I got $55 for it. Visual complex analysis. So this is also a very good book that use the latest visual and graphical, nice explanations of complex analysis. Oxford University Press. Here's a linear algebra done right. Oxford, step by step. So there's Axler's linear algebra done right, and then this is linear algebra step by step. Your workbook. So linear algebra is one of the most important topics in mathematics. So a lot of books on the subject. Proof theory, Takudi, popular book, and set theory. Another Studies in Logic, volume 102, Foundations of Mathematics. This is Elsevier Press. So another, popular people have a degree in mathematics probably know Elsevier Press. My father has quite a few of these books, but like Springer, Birkhauser, Oxford, Cambridge. There's also Elsevier, set theory. A lot of them cover the same topics. So, God willing, I will eventually have time to read these books, study these books. So now I'm getting to kind of more popular books. These are popular books written about mathematics. So, here's some Dover books. So first I have the Dover books that are more textbook style. So put my Dover books together. So here's another Smolian book. I mentioned Smolian, Springer. So here's First Order Logic. Smolian's a popular author. He has textbooks and popular books. So I have a lot of Smolian books. First Order Logic. Here's Dover Hartog's Mechanics, somewhat related to physics, that covers the basics of mechanics from a mathematical level, like levers, springs, Newton's law. Lee Algebras. So Lee is a name who developed a method of algebra. So this Jacobson's books on Lee algebra. Here's number theory. So these are all Dover books. Dover books are relatively cheap. I just sold a copy of this. I sent it overseas. Someone bought this. You probably paid more in shipping. Maybe, I guess it's hard to get Dover's book that they would pay to ship it across the seas. Because Dover books. I think I only sold it for $8. This one, ordinary differential equations. So, Dover are one of the cheaper publishers of mathematical stole set and logic theory. Here's Dover Challenging Problems in Algebra. And the USSR Olympiad problem book. So the USSR had, math Olympiad for years and would have regular problems. So just while I'm doing this, I can put my Dover books together. So here's another 100 great problems of elementary mathematics. So all kind of, general good books to read. And here's Boyer's The History of Calculus and Its Conceptual Development. So another book, I had Edwards, The Historical Development of the Calculus, and here's Boyer's The History of the Calculus. And I recently read that book also. And another one, The Moscow Puzzles. So I recently read this one also. I have multiple copies, so I even have this one for sale. The Moscow Public Books, 359 Mathematical Recreations. So pretty good books. So putting my Dover books together. I have some physics ones. So, and here's Elements of Theory of Functions and Functional Analysis. So, so the Dover books are a little bit cheaper than, the Springer books. So some of the Springer books are better. Like the Dover books are usually older books that the copyright has expired on. So the reason the Dover books are cheaper is because they're older and the copyright has expired, and therefore they could print them at cheaper prices. So here's the American Mathematical Society, terse introduction to linear algebra, problems in mathematical analysis, real numbers, sequences, and series. So, a lot of the same topics from different publishers. And, a lot of people ask for book recommendations, and it's tough to give book recommendations. If you're really interested in the topic, you really should just read a whole bunch of books. So, here's Principles and Techniques in Combinatorics, another interesting field of mathematics, combinatorics. Another book, Stanley's Enumerative Combinatorics. So, a budding important field of mathematics. Here, I showed these on Week in Review from Quantum Magazine, Alice Meets Bob and the Wall of Fire, and the Prime Number Conspiracy. So these are collections of articles from Quantum Magazine that are somewhat physics related. Here's a book on Galois theory. Galois, one of the earlier theoreticians on algebra, very important to the modern understanding. Also, the gamma function. I even forget what that was, so I have another one of those for sale. Here's Hodel's An Introduction to Mathematical Logic, another Dover book. Here's Mathematical Logic, Oxford Textbook in Logic. It's all very good books. So this is a really good book here too. Leonard Euler, Mathematical Genius and the Enlightenment by Kellinger. And this is a biography that includes, it doesn't have like mathematical formulas, but it has quite a bit of math. It's a long book, a biography that includes his life, the early work, the Bernoullis, the Royal Societies, his relations, what he did for, relating to cartography and various things for the state, to the history of his theories and writings. So this is a very good book. Princeton, Leonard Euler. Here, Pie in the Sky, Counting, Thinking, and Being by Barrow. An Oxford book. Just I think I read to look at this book. I think it's an overview kind of on the role of mathematics and thinking. This was a very good book. I read this recently. I think I even had a few for sale. I think I sold my copies. But the story of I, the square root of -1, and the imaginary tail. So people knew about I, the square root of -1 for ancient times, to Euler, who popularized the I to represent the square root of -1 to larger mathematics. This is a good book. George Cantor, his Mathematics and Philosophy of the Infinite. So Cantor, father of set theory, very important book on overview of Cantor's books. This I bought at Stony Brook. You can see Stony Brook Library. I bought it used because at the time, Philosophy of Mathematics. I think I have a copy for sale, or I think it's sold. But selected readings, edited by Hilary Putnam, Philosophy of Mathematics. And I've shown these on Week in Review. These are the Cambridge Student's Guide. So nice. These are, I guess, upper level companion books. So the Student's Guide to the Schrodinger's Equation, Maxwell's Equation, Entropy, Vectors and Tensors, Infinite Series and Sequences. So my dad has almost the whole set of these. Probably not. There's probably, I don't know how many of there are. My dad has like 20 or 30 of them. So like there's probably a lot more than just those. But those are very good books. I read this one recently, The Book of Forces, just kind of introduction to the various forces in physics. Another one, Pinter, a book of abstract algebra, another Dover book, and Magic Squares and Cubes. So magic squares are interesting. Like I'll show also, I have the Arthur Benjamin, mathematician. He does a lot of magic squares. But there's a long history to magic squares. They exist in ancient China and across the ancient world. And then there's interesting mathematics related to magic squares. Okay, so getting up there. So this is a famous book, forward by Douglas Hofstadter. I reread this recently, Gödel's Proof. Gödel's incompleteness theorem, one of the most well-known, important theories of, so to say, mathematics and logic. So I have quite a few books on it. This is a good book on Gödel's incompleteness theorem. An older book also, so rewriting with a forward and explanation. Introduction to Theory of Sets, another Dover book. I talked about this on Week in Review, the Hilbert challenge. So Hilbert was the, Hilbert space, people who know, study a lot about physics, very important. So Hilbert was the regular lecturer at the Royal Society of London, and he collected together the most important unsolved mathematical puzzles of the day. And this is a very good book, The Hilbert Challenge, Jeremy Gray, where he lays out the various, the history of Hilbert and his role at the Royal Society, and the questions of the day that were defined as the Hilbert Challenge, that he set forth the most important puzzles, and I think they even had money to pay people who could solve these, and then the history of including Fermat's last theorem and other important topics. Some of these have physics also. So here is Fermi's Enigma, the epic quest to solve the world's greatest mathematical problem, about Fermi's last theorem. And this more, not really a mathematical book, like popular mathematics, where talks from a non-equation level about Fermi's last theorem and the solution. Mikhail Kaku, Parallel Worlds, A Journey Through Creation, Higher Dimensions, and the Future of the Cosmos. So popular physics books. Pete's Blackfoot Physics, modern version of the Tao of Physics, talking about kind of like Native American folk wisdom in relation to modern physics and in the philosophy of physics. Interesting book. Another Dover book, The Short Account of the History of Mathematics. Brian Greene, The Fabric of the Cosmos. So, Brian Greene, one of the most popular author of popular physics. Mathematics as a Cultural System. So this was an interesting book. I read this book in the last few years, from like a philosophical level, and like we talk a lot on like week in review, and like Greek wisdom, and philosophical level on what is math. Does it represent fact or a cultural system? Kind of like footnotes, essential logic, quick access to. I read this book again recently. E, the history of the number, from the earliest conceptions to the idea of E. E is a unique principle where E is the integral and derivative of itself, and from Euler's famous equation, the E is you considered Euler's number as precursors to earlier. So interesting book. Complexity, the emerging science of edge, order, and chaos, by Waldrop. Some complexity. This is a more popular explanation of mathematical ideas. This is another important book. Just a basic biography, The Man Who Changed Everything, The Life of James Clerk Maxwell. This is a pretty good book also. Travels in Fourth Dimensions, The Enigma of Space and Time. You're kind of a layman's explanation of complicated ideas. The Clockwork Universe, Isaac Newton, The Royal Society, and the Birth of the Modern World, by Dolnick. So I had a similar book on Freemasonry that covered Isaac Newton, and from the Freemasonic point of view as the head of the Royal Society as a Freemason. So this one's more a non-Masonic, general history view of Newton. This is a very popular book. I read it recently. Paul Erdos, In the Search for Mathematical Truth. This man has like the most authored papers on mathematics of any person ever. Was eccentric, a Jewish man. I think he lived in Israel for a while, born in Hungary, but the man who loved only numbers. John Derbyshire, interesting man. He's a writer on Unz. It's kind of right-wing politics, but on Riemann and the greatest unsolved problem of mathematics, the zeta function. So this is a pretty good book that covers the zeta function and a lot of the related mathematics necessary to understand it. And Brian Unz also, he's on the Unz for kind of right-wing talking points. The Man Who Knew Infinity, The Life of the Genius Ramanujan. My father has the complete collection of Ramanujan's notebooks, but the Indian genius who briefly lived in London and then died death young, and had rediscovered some insights, mathematical theories, but on his own had discovered a lot of famous theories. So it was made into a movie. So I believe that book was, I read this one recently, E equals MC squared, Biography of the World's Most Famous Function, David Bodanis, popular science author. The Birth of Time, John Gribben, How Astronomers Measure the Age of the Universe. You kind of like physics overview. In Code, interesting, like high school girl who won national competitions for cryptography, and then kind of was a spokesperson for mathematics, but didn't really amount to that much. So there's a lot of media hype about this woman, like a young mathematical genius who had theories in cryptography that turned out not to be as sound as thought, and but she was a big media publicity in Ireland, had as a youth for winning mathematical competitions and theories in cryptography, but an interesting biography. The Magic of Math, Arthur Benjamin. So I believe I have this book autographed. So Benjamin had came to the backgammon. And actually I got a copy of this book from my father also. So I bought this book, and I bought another copy for my dad and gave my dad a book. And so Arthur Benjamin was the world backgammon champion. He has courses on the great courses on mathematics and secrets of mental math. I also have this autographed. So he came to Michigan for the backgammon tournament and was signing books. So very interesting, methods for doing math in your head. I also have his great courses, Love and Math, The Hidden Heart of Reality, Edward Frankel. This was a New York Times bestseller, but I didn't really get that much out of it. I guess like a Russian Jewish mathematician who moved to the U.S. and he wrote a biography, had some advancements in mathematics. This is a good book, Studies in Logic and Probability, George Boole. So I mentioned Boolean algebra. Boole is kind of one of the fathers of logic and computer logic and circuit logic. I just finished this book yesterday. I tried to finish it before today. I showed it on Week in Review, Elements of Scientific Inquiry by Martin and Ascherman, which is kind of like puts in a philosophical mathematical logic foundation about the nature of scientific law that includes the scientists and the environment. So a very interesting book. Hope to go more in depth on some of these topics. Robert Lomas, the popular Freemason author, the man who invented the 20th century, Nicholas Tesla, forgotten genius of electricity. Been showing Kathy Loves Physics, her series. So she's been covering Westinghouse and Tesla recently, so it's good material. So here's Robert Lomas, the same popular author of Freemasonry I covered on my Freemasonry book, wrote a biography of Tesla. These are good books. The very short introduction. My dad actually has like close to the whole set of hundreds of these books. So here I have other ones, but here are the science-related ones. A very short introduction to relativity, magnetism, stars, and climate. So good series of books. The New Cosmology by Peter Coles, which is a dictionary of physics terms. I bought that when I was in Stony Brook at the Stony Brook library. So getting to the end of these here soon. So good book here. Faraday, Maxwell in the Electromagnetic Field, How Two Men Revolutionized Physics. More history. Here, astronomy, the DK Eyewitness Companion to Astronomy. Remarkable Mathematicians from Euler to von Neumann, Cambridge Press, good book. Like I said, I know quite a bit about the history and philosophy of mathematics than the actual mathematics itself. So I showed all these textbooks, graduate level, upper level textbooks, and most of these I haven't even looked at, like for reference. So you look at occasionally, but these books I read regularly. I read every week. I probably read a new book, like one of these, and I have like tens of them on my shelf. Biographies, History of Math and Science, Philosophy of Math and Science, Its Practical Implication. So here's Newton and Empiricism on kind of the philosophy of science. Einstein's Dice and Schrodinger's Cats, How Two Great Minds Battled Quantum Randomness to Create a Unified Theory of Physics. It's a pretty good book. John Derbyshire again, Unknown Quantity, A Real and Imaginary History of Algebra. I have a few of these for sale. Derbyshire is a popular author on the Un's Review. Special Relativity from the Ground Up. Another introduction to Einstein's special relativity. This includes some math. Okay, so The Great Scientists from Euclid to Stephen Hawking. Big fan of these books. So I get my camera to reset. So 1 second. Walter Isaacson, Einstein Biographies. So I've been talking with John Wolfe on in Louisiana at Tulane College, popular author Walter Isaacson on Einstein's biography. That includes quite a bit of an explanation of some of his scientific ideas, but more is a non-scientific biography. Popular author Walter Isaacson's. I've even that book for sale. Origins, Neil deGrasse Tyson and Goldsmith, 14 Billion Years of Cosmic Evolution. Neil deGrasse Tyson, one of the most popular physics popularizes authors. Lawrence Krauss, Hiding in the Mirror, The Mysterious Allure of Extra Dimensions from Plato to String Theory and Beyond. So, popular explanation of modern physics. The Rise of Early Modern Science, Islam, China, and the West. Another history of science. I have other books on the history of technology and engineering. So I probably have like another shelf of books. I have other math books that I probably didn't find, but I have a whole shelf probably worth separate, that like engineering, technology books that I kept separate. Foundations of Modern Science in the Middle Ages, 3 Religious, Institutional, Intellectual Contexts. I have some books also like on Islam and the Islamic history. Here's George Gamow, 30 Years That Shook Physics, The Story of Quantum Theory, written by George Gamow himself. One of the key player. Here's The Evolution of Physics by Einstein and Infeld himself. So Einstein himself wrote a book on the evolution of physics from early concepts to relativity and quanta. The Infinity Puzzle, Quantum Field Theory and the Hunt for an Orderly Universe. and Edge of the Universe, A Voyage to the Cosmic Horizon and Beyond. So with that, I'm going to take the camera out. So I'm going to ramble a little bit. So 1 second. Okay. Give me 1 second. To move back to my desk or table. So I just bought and built that bookshelf this week. And I pulled out my math books. So, a lot of those were the new math books that my dad gave me recently. And then there were also various math books I took off my shelf that were unorganized. So part of me doing this is my own organization of my my library. So I just went back to my desk. So hopefully this was a little bit interesting to some of the people, like God forbid, like suffering like about a depression, like meaning of my life and what I'm going to do with my life, and existential crisis about Judaism and various things. But I constantly study math and physics. Like I showed from my early university books to I originally thought I was going to get a degree in physics. Hey, Rune, nice to see you. So originally I had been pre-med and I wanted to get an undergraduate degree in physics. And it didn't work out like that. But, I took quite a bit of, I probably have like 50 credit hours worth of math and physics courses at university. And my whole life, I've always read math and physics books, like kind of, history, philosophy, but also, puzzle books, computative books. Paul asking if it's a coincidence that almost all your books are by Jewish authors. Well, I don't think that's accurate. So a lot of the popularizers of math and physics, there's a lot of Jews involved in that. But I probably only like 20-30% of those books are by Jewish authors, maybe even less. And I mean, so like Weinberg, so there is a disproportionate role of Jews in math and physics, but especially the popularizers of math and physics. But I don't think that it probably 20-30%. So we'll save that for a different level. And so when I was in yeshiva, math and physics was not that popular. Like most people didn't have a background. There were a handful of people that like when I was in Israel, I had a handful of books on puzzles and logic. I would come home and I would bring like a book on puzzles or a book on like mathematical logic. Hey, The Truth, good to see you. So Tinkle Tank, How to Prove It Classic. Yeah, I think I had How to Prove It. Pretty sure. Actually, I'm not sure. I had the Book of the Proof. My father definitely has How to Prove It. The title's familiar. I was just organizing my dad's book. So I'm not actually sure whether I have How to Prove It. I think I do, but not, so if I covered it and I already forgot, God forbid, short-term memory. And, there's, I went through a few hundred books. So I was mentioning that a Bubblvis, dissident physicists. Yeah, I'm not an expert on physics enough to think dissident theories. I have a lot of books like Spiritual Physics. If you think like alternative approaches to physics or math, most people are, who write books are from products of the Academy, historically the Royal Society, to getting a PhD. Even like Eric Weinstein is like a dissident mathematician. I don't have Eric Weinstein's book. I don't even know if he wrote a book. So most of these books are more mainstream textbook. So I said I constantly study math and physics. I have on my desk right now, a history of analytical geometry. I'm looking at this book right now, Boyer. I had other Boyer book on, and the first course in logic. This is the Oxford Text and Logic, the book 1. So first course in logic. So these ones are actually on my desk. That the other day, I read a few chapters in this. I finished a few books. So like I would say at least one book a week. I go through a book, maybe like a popular book that doesn't have any math in it, but probably like one book a week I'll go through that has math in it. The longer books, like eventually I'm going to start going through those Schwichtenberg books on the no nonsense introduction of physics. Something like the Princeton encyclopedic that would maybe even take a month or two. Some of the more complicated books, especially the ones that have a lot of math, like sometimes I'll just skip through and not really do that well. But the more complicated books, God forbid, take a lot of time. Time is limited. Like a textbook, like the Springer books. I could probably do a chapter a day, so like it might take me 30 minutes to an hour. And I'm reading stuff online right now of just online books. Some of them freeware books or bootleg books or Kindle books that I don't own. So I have on my computer right now. I'm trying to go through I mentioned on Week in Review, the Cambridge the Handbook of the History of Logic, 11 volumes. So I'm hoping to do a chapter a day, and I'm falling behind. But if I could do like 5 chapters a week, the 11 volumes, the Handbook to the History of Logic, would take me like 2 months. So, that just kind of like leisure reading without actually doing problems. Because mentioned Lex Friedman, the best books are textbooks. So really want to understand something, and you're actually going to take out a pencil and paper. And I never take out a pencil and paper. I almost never do that. I would actually take out a paper and pencil to work on problems. So I have those other books that have worked problems. This is my father, to actually take out a paper and pencil to work problems. Okay, I'm too old for that. God forbid I was in school and my dreams of advancing in the field didn't work like that. I don't work with the fields. Like I mentioned, I showed at the beginning, the COMSOL, the computer, that if I was working in the field, it would probably be at a computer. But yeah, it does pay to work actual problems, or at least to go over books that have worked problems to keep your mind fresh, like with the systems 1 and 2 thinking, that you want your mind to be active. And so hopefully Jennifer, a Week in Review, and she sounded interested in maybe writing a book on the history of signal processing. I only saw one book on the subject from the IEEE, and it didn't look that good, but that might be a good academic exercise. You can see some of these popular authors that pump out lots of books. I mean, like Alan Dershowitz, who law professor, has written like 50 books, or his name's slipping me. Deepak Chopra, who's written like 100 books, versus someone like Lawrence Krauss, who's maybe written like 10 books, and even some like Smolian, who's maybe written like 10 books. That I want to get into the writing progress. See, like I'm doing the tour of my library partially for my own benefit and to organize my own thoughts. But yeah, I think that I could write a book. And so hopefully maybe me and Jennifer will work together if it's interesting to her to, I want to write a book on the the multiple truth hypothesis. And so like I have the math books as reference, that the multiple truth hypothesis will have a mathematical logical form. And the formulation of the multiple truth hypothesis will at least have a chapter that will have a mathematical logical form. And so I have to keep on reviewing and do some research. And I think the multiple truth hypothesis would actually be useful for physics. And the level that I'm going to produce like a theory on physics, God forbid, time is short. I'm already turning gray, but so I'm going to try to get through those Schwichtinger books, maybe the Weinberg books, some level. But the multiple truth hypothesis book would at least have a chapter that would basically be mathematical logic notation of the concept of the multiple truth hypothesis, and maybe another book that would be on the algorithmic truth discovery function, as to how it would be put into the computer. But then also just interest me, like, so what does it do? What's the purpose of it? The science, the philosophy of mathematics. That the multiple truth hypothesis might be more in the realm of the philosophy of mathematics than actually as mathematics and like a grand unification theory, where I'll probably return to these books and more, and maybe I'll go over all these various aspects: analysis, model theory, proof theory, combinatorics, linear algebra, the division of the current state of mathematics, as I get more into the multiple truth hypothesis and why there's all these divergent fields. Certainly logic right now, I'm making an effort to read this whole 11 volume, like 10,000 pages of the history of logic. There's definitely more coming. So this is kind of like a work in progress. So, for my own benefit and, the benefit of my viewers, my friends, my study partners, that, thanks, Bob. Yeah, I'm not sure there's any more engineering conferences coming up. I used to go like University of Michigan or something, like symposium or something like that. Like I said, I plan on going to Italy. So tentatively right now, I haven't bought a ticket or renewed my passport yet, but tentatively I plan on going to the Science of Consciousness conference in May in Italy, Sicily. So anyone Week in Review Duvid fan that wants to meet up, might be a good international trip meeting ground where, the Duvidians could meet in Italy for the Science of Consciousness conference, who travel to Rome, the Vatican together, see some historical sites, and attend the Science of Consciousness conference. That's in May next year. But there's the regular Michigan conferences that have all, like the Battery Show, the Automotive Testing Expo. Those are over. I'm not sure there's any major shows in the winter, so there might not be another engineering show till the spring. But if they do, we'll see. But I mean, any serious Duvidians out there, consider meeting up in Italy in May for the Science of Consciousness conference, and maybe we could split some rooms and attend the conference, maybe even rent a table, and then we'll travel and go to like Rome and something. So that's tentative plans to go to the Science of Consciousness conference in May. But yeah, I'd like to start producing some more videos. So it's over the next 2 months. I'm going to stream every Wednesday, 4 o'clock, God willing, on the tour of my library. And I definitely, like the Judaic, I could at least 2 episodes to cover my Judaic section. And, I definitely have one on business, on philosophy, on psychology, on consciousness, on politics, on Christianity, multiple ones on Judaism, probably on engineering and the non-civil engineering or math and physics engineering. And I actually have some really good books on engineering that I didn't include yet. maybe even one like politics, law, so even literature. But definitely business. I have a good one coming up on business books. We definitely have like 2 or 3 shelves on business books. And Hanukkah, like I'll probably try to get my Judaica one starting Hanukkah in 3 weeks. So hopefully 3 weeks from now, I'll start my Judaica books in the middle of Hanukkah. And then, so maybe 3 weeks from now will be on Hanukkah. So I'll start my Jewish books, and then I'll actually take a break to light my Hanukkah candles during my Judaica books. So, keep this going, and hopefully, reach out, and people want to talk. As I said, like I would like to reach out to Jacob Schwichtenberg. Maybe he even talk to me, the popular author of physics books. And there's some other people, like maybe I would reach out, try to do more interviews. Like the JQ, Kanye, big out there, like Adam Green, Luke Ford. I'm not sure if I'm going to stream with Charles Moskowitz. If he reached out, like I'll talk to Charles tomorrow. But I'm not really sure where that's going. But so obviously the Jewish stuff is my biggest topic. I'm going to also do another Ask the Rabbi. So over Hanukkah, I plan on doing a Hanukkah either on the soul or the origins of the Noahide laws or the Jewish-Gentile distinction. So I'll probably either do the origins of the Noahide laws or the Jewish-Gentile distinctions, maybe even 2. So I'm going to try to do the Ask the Rabbi coming up in 3 weeks with the Hanukkah. You got Mob Talk on Mondays with John Wolf now. He's got to buy a mic if he wants to advance in streaming. Keep on doing it. Like he'll have to, we might run out of material, so he'll have to consider making some investments or upping his game, to advance in streaming. So as over the next month, 2 months, as I organize my library, it'll help me organize my thoughts, and keep me streaming daily. I mean, at least once a week for the next few months. And then from there, I'll probably start putting out some material more on the multiple truth hypothesis, working towards a book. If Jennifer gets more serious about it, her writing, maybe we'll also make some advancements. And I'm going to look to try to start having guests to interview. And, maybe I'll try to contact some more serious authors. Thinking like maybe Jacob Schwichtenberg, maybe stuff related to consciousness, maybe preparation for going to the Science of Consciousness conference. Maybe I could get like a bigger name in consciousness that would give me an interview on my channel. So, I also have a shelf of books on Michigan and Detroit literature. Could also do that. So I'll probably keep the Tour of My Library book series going for a few months on Wednesdays, and from there I'll work into what I'm going to do. I also have a section of African Black America books. So I think Bob put on some of my 3-hour podcasts to fall asleep to and end up staying. Well, I appreciate that, Bob. And if you ever want to talk or come on, I don't know if you're related to Paul. So I appreciate you watching my content, and if you have any thoughts on this, so these are kind of random, so I'm giving my academic background, kind of what's going through my head, the stuff that I'm focusing on, and I'm going to try to make some more organized content. And I want to get more serious. I want to start writing books. I'm going to put myself together. I took myself off the chess server. I streamed the Horde tournament yesterday because whenever no one else is doing it, I've been playing that game. I was one of the best in the world, and one of the participants asked me to stream it, so I streamed it. But I'm focusing less time on chess. The chess server is not the right venue, so I think I'm going to open up my own webpage to start my blog. So I'll have to buy duvid.com and make my own webpage to host a blog So hopefully starting next year, I'm going to take my own writing more seriously. I'll buy my own webpage and start putting articles on it. I'll try, maybe even try to, maybe I'm considering, it'd probably be the UNS review. If I could, write more Jewish political related stuff, maybe they would pick me up on the UNS review. I'm not sure, but like if that would probably be, because I've spoken to quite a few of the people on the UNS review, like Kevin Barrett, E. Michael Jones. It's possible that I would be able to write for that, for more political stuff. I'm not sure how many Davidians there are. I'm not really sure. The people who follow my content, I have over 2,100 subs. A few hundred people watch my videos. Get some regular names in the chat. Luke Ford, various shows. So I have to produce my own content, like the Judaic stuff, and advance the multiple truth hypothesis, and what does it mean to be a Davidian. So when I get to the Jewish stuff, you start seeing some of the Kabbalah stuff that might also clarify it, because Kabbalistic works is definitely a big part of Davidianism. So I think I'm going to wrap up. And this guy Justin Josephs just messaged me. He was on Week in Review, Talk with T-Jump. So maybe I'll reach out to him and have him on my channel. Also, I just see he messaged me. So I think I'm going to sign off. I'm going to eat, and we'll keep this Wednesday regular tour of my library going. It's useful for myself, and hopefully for my regular viewers to see kind of the making of Duvid and the intellectual background, what I keep myself busy. So okay, like God forbid I'm an older bachelor. Thank God I'm in a situation where I basically only work part-time, a few hours a day, and I spend most of my time studying, reading in all types of fields. So I spend a few hours a day studying math and physics, and what I'm going to use it for, I'm not even sure, because at this point I don't have a job-oriented goal towards my studies. So it's just kind of things that interest me. I like to understand things. So I have to, think more about what I'm going to do with this stuff, and maybe into writing that, I still go into engineering conference. I have a whole bunch, on the ground here from, the conferences. I'm not sure, see on the floor there, these are all pamphlets that I've gotten at recent engineering conferences that I still haven't read yet, that, hopefully I'll take a look at those, and, like, God forbid, I could do a whole series of like engineering pamphlets, organize those, and maybe I just recycle them. But, I have thousands and thousands of these pamphlets and profiles. A lot of them are pretty interesting, like technical equipment, industrial profiles, and, like, if I would actually work in a field of construction, cost estimating, scheduling, facilities management, 3D printers, just find this book. You really want a great book, Reconfigurable Manufacturing. Like, I'm going to do later on, but like, I would like to get more practical. I also probably have a shelf of books on biology, genetics, or science. I'll have to, as I organize my library more, so this is a good intellectual exercise for me, organizing my library, thinking about the stuff I've studied in the past, what I'm going to do with my future, intellectual, and I'm going to try to start writing, and we're going to try to write a book. If Jennifer's game, maybe we'll co-author this book on signal theory, and I'd offer her to join, but I don't think she's going to be back in time. So signing off. Shalom, Hare Krishna, blessings, and thanks for tuning in. Thanks for following my content, and my friends in the chat, the Davidians out there. Any recommendations, let me know. And so God bless. Have a great night.